Hi, welcome to this webinar session. Today, we are going to be looking at some basic introduction to statistics. So let us get at it. We are going to be looking at what descriptive statistics is all about, and we are going to be looking at measure of central tendency. We are going to be looking at the measure of dispersion and 5-number summary. If we are unable to finish all of this in today's session, we are going to be looking at the remaining in the next webinar. Let's look at descriptive statistics as a whole. We are going to be looking at what statistic is. We look at the branches of statistics. We are going to be looking at some important terms that we need to understand when it comes to statistics. And then we are going to see how statistics is important to our data analysis process decision making. Statistics is the study of data collection, data analysis, and data presentation. Like I said in one of our earlier seminars, in fact, the first seminar of this course, that statistics, or let me say that statisticians have been doing the work of extracting information from data for more than a century. So extracting information from data, or what we call data analysis or data analytics today, is not a new thing. It is something that has been with us for a long time. And statisticians have been the ones which are saddled with the responsibility of carrying out these tasks. There are two broad components of statistics, which are the descriptive and the inferential statistics. Descriptive statistics summarizes and it explains the key feature of the data, that is, some of the direct findings we can extract from a data set. While inferential statistics help us to make some estimated conclusions and estimated inferences about the population based on what we are able to get from the sample collected from that population. So descriptive statistics is simpler than the inferential statistics because inferential statistics is more technical and it is the one that involves some of the advanced statistical models and hypothesis testing. Let's look at some of the important terms. Let's look at qualitative data versus quantitative data. Qualitative data are data in form of names and attributes that cannot be counted or be represented in form of numbers. While quantitative data, which are also known as the numeric data, are those ones that can be represented in form of numbers and they can be counted. Qualitative data are also known as categorical data. So if you hear the word categorical data, then we are referring to qualitative data. And when you hear the term numeric data, you are referring to quantitative data. Qualitative data can be in form of nominal or ordinal data, while quantitative data can be in form of discrete and continuous. So, like we said nominal and ordinal are types of categorical data, while discrete and continuous are types of numeric data. Nominal data or the term nominal is used to refer to categories without an inherent order. For example, if we say, what is the gender of the students in the class? So we say, okay, male and female, that cannot be put in, you cannot order those particular components. So we can't say that that male gender is of higher rank than the female gender, and we can't say vice versa. But ordinal data means that they are categories, but within that category, there are some inherent ranking or orders. For example, let's say academic qualification. So academic qualification can say, okay, this is O level, this is graduate level, this is postgraduate level, PhD level, and so on. But inside these categories, there are rankings. You can say PhD is of higher rank than masters, and masters is of higher rank when compared to the BSc category. So when we can derive an inherent ranking in a particular category, we say that it is an ordinal data. Discrete data means that this particular data can be represented in whole numbers, and we cannot put them in decimal points. For example, if we say how many students are in a particular school, we can say there are 101.5 students. It's not possible. The number of students has to be in a whole number. Then such data is categorical data. So if you say number of students in this class, then it is a categorical data as long as we cannot represent that particular value in a decimal point. Continuous data are those that take decimal values. For example, let's say, what are the weights of students in a particular class? Then you can have 50.1, 50.2, 60.5, and co. That is a continuous data because we can represent it in a decimal point. If we say, what are the scores of a particular, of the students in a particular class? That is a continuous data because a student can score 60.5, 60.1, 60.9, and co. Let's look at some other important terms that you are going to be encountering in your journey as you are trying to become a data professional and you want to be employing the principles of statistics. The first is the population. Population is the totality of all the members in a particular group. So when we say, okay, this is a group, when we put every individual, every member that belongs to that group together, we are referring to the population. For example, let's say we go to a particular school and we say all the female students in that school, every female student in that school, that is a population. If we say all the male students in that school, every one of them, that is a population. If we say all the Toyota vehicles in Nigeria, that is a population. Then we talk about sample. Sample because most of the time it is very difficult to measure every member of a population. For example, if we say we want to measure the height of all the female in Nigeria, you can see how tedious and how costly that will be. So the point is, can we just take some subset of the population and measure the attributes in that sample and we use it to estimate what the actual value of the population is? And that is where sample comes in. So sample is a subset of a population that we use to make an inference about a population at large. Then we have variable. Variable is any attribute of a population that can be measured. So assuming we go to a school and we say, okay, the height of all the female students in the school, the weight of all the male students in the school, as long as we can measure any attributes, any characteristics, or any feature of a particular population, then we can say that that particular feature, attribute, or characteristics is a variable. Then we talk about parameters. It's a value that we derive from the whole population. So when we measure a particular variable from the whole population, that is, we measure every member of the population, whatsoever we get is called a parameter. And like I said before, this is usually not achievable. However, in some instances where the population contains members that are very scarce, in such situation, you can actually have all the members of that population measured. But it's not usually the case in the real world. Then statistics. Statistics is a value derived from the sample. So which means that if we cannot measure the whole population, we can use the sample. And whatsoever we get from that sample is called the sample statistics. So in conclusion, we have been able to look at the statistic that it is a branch of science, or let's say a branch of mathematics, which deal with collection, analysis, and the presentation of insights derived from data. And like I said before, statisticians have been the one in charge of data collection, data usage, and co for more than a century. And we spoke about the branches of statistics, which are the differential, the inferential statistics, and the descriptive statistics. And we spoke about the important terms, such as population, sample, variable. We spoke about parameters and the sample statistics. We also spoke about quantitative and qualitative data. We spoke about quantitative data as numeric data and qualitative data as categorical data, and that categorical data can be ordinal and it can be nominal. And we say that nominal is when there is no inherent order in that category, whereas we say for ordinal, there are inherent rankings, like the academic qualifications. Whereas when we talk about qualitative data, we spoke about the discrete data and the continuous data. Discrete is when we cannot use a decimal point, but a whole number, like the number of students in the school, which cannot be in decimal points. And we spoke about the scores of students, which can be in form of decimals, the height can be in form of decimal, and the weight can also be in form of decimals. And those are examples of continuous components of the numeric data. And we spoke about the importance of statistics, that you cannot make a reasonable amount of conclusion or get some in-depth insight into the data without applying some of the basic statistical concepts. And in fact, the more advanced you want to go in the level of analytics, the more understanding of some of the advanced concepts of statistics that will be required. So let's look at the second topic for today, which is the measure of central tendency. Let's look at what they mean We are going to compare them, and we are going to look at when we can use them. So, measure of central tendency is what you use to measure, or when we are referring to a particular value that best represents the center of a data set. For example, if we look at all of these different arrows, and we want to look at a particular arrow that represents the height of these ones, I believe you will agree with me that this particular guy over here, can be used to represent the height. The height of this guy can be used to represent the whole height of the values here, of the arrows here. Even though this particular arrow is taller than this, and this one is shorter than it, yet this arrow is representative of the ones here. Now let's look at the common central tendencies that is often used in statistics: the mean, median, and the mode. So the mean is also known as average. You know, the word average is what everybody uses, but that word is not a layman term, it's actually a technical term, and that shows how much statistics has invaded our daily routines, even though we do not know. The median is the middle value when the observations have been sorted. So when you want to check the median of a particular data set, that data set has to be sorted in a descending or ascending order. And after doing so, the middle point is the median. However, in some instances, we can have 2 points at the middle, usually if the number of observations are even. So in such a situation, we add those two values together and we divide them by 2. And whatsoever we get is going to be the value for our median. Mode. Mode is the most frequent value of a particular data. Mean is commonly used, and median is robust to outliers. I spoke about outliers in our data cleaning seminar, where we said that when we are cleaning our data, one of those things we want to check is outliers, because outliers can impact our conclusion. And one of the ways to avoid the influence of outliers is to use median as our central tendency, because it is robust to outliers. The same thing goes for the mode. Mode is also robust to outliers, but mean is very sensitive to outliers. And we are going to see how that plays out as we continue in this session. So we use median if there is an outlier in the data set, and mode is often used in categorical instances. And it is important for us to know that a data set can have one mode, it can have no mode, and it can have more than one mode. So if you see a data set where you cannot really get a mode, don't be surprised. And if you have a data set with more than one mode, don't be surprised too, it is not something new. So if you look at all these points here, you can see that the height of this arrow is fairly disproportionate compared to others. And that is why this particular arrow is an outlier. If you also look at this is very short, is disproportionately shorter than other arrows, and we also say that this is an outlier. So if we remove this and remove this, in terms of the mean, this guy will represent well. But if we put all of them together, if we use this guy as a median, you see that these ones are not impacting it. But let's look at this in a more intuitive manner. Look at these values here. If you calculate the mean of this value, we are going to get 3. So 3 is the mean of this value, and you can agree with me that 3 is actually representative. It's a good value that we can use to represent the whole of the numbers here. But if you look here, the values in this line is the same thing with the ones in the first line, apart from the fact that this 3 here has been changed to 33. So because you can see that this 33 is an outlier, it is disproportionately higher than other values. And let us look at what our mean has become. When we add that outlier, you can see that our mean has become 6.3. And you can also agree with me that 6.3 does not represent this well at all. It doesn't. And why? It is because of the influence of the outliers. That is why we say that when we have an outlier, mean is not usually the best option because of its sensitivity to outliers. However, let us use this same value and let us rearrange it and look at the median and see if our median is going to be impacted by this outlier. And here we are. So when we rearrange it, we have this, and then our outlier is 3, which is actually representative of this particular value here. So using 3 as the center of this value is very okay, despite the fact that this 33 is there. And that is the power of median when it comes to an outlier. In conclusion, we have been able to look at the measure of central tendency. We look at the mode, the median, and the mean. We spoke that the mean is good, is great, but it has only one cardinal weakness, which is its sensitivity to outlier. And we say that if we have an outlier in a data set, it is either we remove those outliers and use our mean, but if we do not want to remove the outliers, then we might want to go for our median. Thank you very much. We are going to be ending this session here, and we will continue with others in the next session. Thank you very much.